So we're going to skip over 16.4 and jump into 16.5, the activity series. So if you put a piece of magnesium metal into a solution of copper ions, you'll get a chemical reaction. And copper will deposit on the magnesium and the magnesium will dissolve. If you do the reverse and put a strip of copper in a solution of magnesium, nothing happens. So why? How do we predict what reaction will happen and which one will not? We use the activity series. It lists metals in order of decreasing tendency to lose electrons. When metals react, they do so by losing electrons. So the metals at the top of the list are the most reactive. The metals at the bottom of the list are the least reactive. So I think of this as a list maybe that the sophomore girls in high school are keeping of who are the hottest boys in the school, right? Who's going to get the most action? It's the boys at the top of the list, right? So here's the list. Lithium is the stud. Lithium, potassium, calcium, sodium, blah, 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 blah. You do not memorize this. You'll be given either the whole thing or the pieces of it that you need. So lithium reacting to form lithium ion is very highly likely to happen. That was a really bad sentence. Is the most likely to occur. Down here, gold and silver reacting doesn't happen very much. So we can, putting a metal in a solution of another metal's ions, we can predict which is going to react by looking at who's most active. And this goes back to the idea with the single replacement reaction of the one metal going to the party by himself and the other one going with the girl. How do we know if a reaction is going to occur? The metal that's higher on the list leaves with the girl. Okay, so, the boy's going, you got this really cool kid and this medium cool guy, but he's got a date and he goes to the party, and it's the cooler guy that leaves with the girl. Okay, you could imagine that happening. Gold is very low on the activity series, which makes it a good metal for jewelry and electronics because it does not react easily with oxygen. It resists tarnishing and corrosion. Iron would not be good for that because it rusts quite easily. So here we're going to determine whether each redox reaction is spontaneous or not. So here's our list. We actually don't need the whole reactions there. We just need the order. So we're going to look at this, and here is zinc without a charge. That's because he's by himself. Nickel here has a +2 charge. He's all charged up because he has a date. We're not telling who the date is here in this equation, but he's coming in with the girl. So is this going to happen? Is zinc going to get the girl and nickel going to go home? We have to see who's cooler, right? So we look on the list. There's zinc, and nickel's down here. Zinc is cooler, more active than nickel. He's going to steal the girl. So this reaction will occur. This one is spontaneous. Because zinc is above nickel on the list. He's more active. Does that make any sense? What if we have zinc and calcium? The one with the charge is the one that has the girl. Okay, he's excited, he's charged up, I've got the girl, right? So here's zinc, no girl, calcium has the girl. Is zinc cool enough? Macho enough to take the girl? No. Here's zinc. Calcium is much higher on that list. So if the girl has to choose between zinc and calcium, she's sticking with calcium. This guy's better, in her mind at least. So this is not spontaneous. This reaction will not happen by itself. Zinc is lower than calcium on the list. Any questions? The activity series allows us to predict whether a metal will dissolve in an acid or not. Some metals dissolve in acids, others don't. They dissolve by the reduction of hydrogen ions. The hydrogen ions come from the acid. We saw this sort of a reaction here at zinc instead of magnesium, but you put the metal in acid and it bubbles and fizzes. That's hydrogen gas being formed. And then at the end, there's no metal left. There's just the zinc ions. So metals that are above hydrogen on the activity series will dissolve. Metals below do not dissolve. So you're looking at, we're going to treat hydrogen as one of the guys, even though, hydrogen is a nonmetal. It's a little conflicted. So here's zinc, and hydrogen's got the girl, and so we can predict whether this reaction will occur, because if zinc is higher on the list, the reaction occurs. If zinc is lower on the list, nothing's going to happen. There's one important exception. Nitric acid will dissolve some of the metals that are below hydrogen. I won't test you on this, I just want you to have heard about it. Nitric acid can dissolve metals even that are below hydrogen on the activity series because it does a different pathway. It has a different mechanism. So, does silver dissolve in hydrobromic acid? So what we're looking at here is silver plus acid. Is something going to happen? So silver's got the girl, he's charged up. Silver does not. So we're going to look over here, there's hydrogen. Silver is lower. That says that silver's not cool enough to steal the girl from hydrogen. So will it dissolve? No. No reaction. Nothing's going to happen. In order for this to dissolve, we'd form hydrogen gas and silver ions. Silver would have the charge, silver would have the girl, whatever that ion is that's in there.